Hey everyone, welcome to JC Tuition's next video where we're going to be continuing our topic of differentiation. I highly recommend that you watch the first video before you watch this one, or just have at least the basic knowledge on how to differentiate and what it actually means when we're differentiating something. So today in particular we're going to be talking about turning points. So let's get started. What exactly is a turning point? The easiest way to think about a turning point is if I first draw a graph for us. So for example, you might have a graph that looks like that. A turning point on this graph is basically a point at where the curve changes its direction. So a curve at this point is going up and then it changes and is going down, right? So it's changing direction here. Or it also works the other way around. If you're going down and then it starts going up, that's another turning point. So those are two types of turning points. So a really important property of turning points that you need to know is the gradient at a turning point. So the gradient at a turning point, so for example, let's call this turning point A and this turning point B. If I were to draw a tangent, if you remember, that's what we're doing when we're finding the gradient at a point. We're basically finding the gradient of the tangent. So the tangent here actually forms horizontal lines. And that is true for every single turning point that you'll see. The tangent is horizontal. So the gradient at that point, as you should know for a horizontal line, the gradient is 0. And that's why for every turning point, the gradient at that point is 0, and you should know that means you can write it in this format, where the gradient function must also equal to 0. So that's all well and good, but there's actually ways of classifying turning points as well that we need to be aware of. So the two main ways of classifying turning points is a minimum and also a maximum. So it's pretty self-explanatory. You can probably guess what a minimum and what a maximum point is, but I will show you so that you know. So a minimum point is where your graph looks something like this, and the minimum point would be here. Okay, so that's a minimum. And a maximum would basically look the opposite, where you've got a graph that looks like that. The maximum point, the turning point is a maximum point. Okay, so sometimes the most common question that you will get with turning points is to find the coordinates of a turning point. So the best way for you guys to understand how to work out the coordinates of a turning point is if we just go through an example. So for example, you might have a question that's like, find the coordinates of the turning point on the curve with the equation y equals 2x squared plus 8x minus 9. Okay, hopefully you guys have figured out that in order to find the coordinates of the turning point, we're going to need to first differentiate. So we first differentiate, and hopefully you should know that that differentiated is 4x plus 8. If you're not sure how I got that, make sure you watch the previous video. Okay, cool. So remember, we're trying to find the coordinates of the turning point. And if you remember, I said that dy by dx at a turning point is always equal to 0. So you've probably guessed it, all we have to do is make this equation equal to 0, because we know that the gradient is equal to 0. And then just by simple rearranging, that gives us x equals minus 2. So that's all well and good. We found the x, but you should know that coordinates mean they want it in this format. You need the x coordinate and the y coordinate. So in order to find the y coordinate, as you would with any other question where you know the x coordinate but not the y, you just substitute it back into that first equation. So y equals 2 times minus 2 squared plus 8 times minus 2 minus 9. And that should give you minus 17. So we know the x, we know y. Therefore, the coordinate must be minus 2 minus 17. Cool. Feel free to go through some of your own examples as well. Okay, so now we know how to find the coordinates of a turning point. A question that you might get asked is if the point you found is a minimum or a maximum. So sometimes that's easy to work out, sometimes it's a bit trickier to think about it. But and this is obviously assuming that they haven't given you, like they haven't drawn the graph for you. For example, they haven't drawn the graph like here. You would obviously know that it's a maximum point if they've shown you the graph. But if you don't know what the graph looks like, there is a quick way to just know whether it's a minimum or a maximum point. So a graph in this general term, so for example, you've got y equals ax squared plus bx plus c. It all depends on what is what a is. So for example, if a is less than 0, so a is less than 0, so you've got a minus x squared term, your graph will have a maximum point. So it will look something like this. However, in the same equation, but you've got a is greater than 0, so it's positive, then the graph, you guessed it, has a minimum point. So if we actually go back to the question that we just did, we had y equals 2x squared, sorry about that, y equals 2x squared, the 2 is positive. So that's how you know that the graph must have a minimum point then, because a is greater than 0. Okay, so it's got a minimum point. Right, let's continue. So obviously sometimes it's not as simple as an x squared term. Sometimes you've got a cubic graph. So a cubic graph meaning something that looks like y equals ax cubed plus bx squared plus cx plus d. So where oh sorry, I said cubed and I wrote squared. Right, so you've got a. So when a is greater than 0 in a cubic graph, you're going to get 2 turning points. The first one being a maximum and the second one being a minimum. And as you probably guessed it, if a is less than 0, you again will have 2 turning points, but this time the first one will be a minimum and the second one will be a maximum. All right. So let's go through one question together that you might get, which should sum up everything that we've learned today. So for example, you might get a question that looks like this. So they've given us the equation of a curve, and the first thing they've asked us to do is find dy by dx, which I am assuming you're all pros at by now. So the answer to A would be 2x minus 4. Okay. The next part is they want you to find the turning point coordinates, and hopefully you remember that to do that we need to make dy by dx equal to 0. So if you remember, part A is where we found dy by dx, so we just make that equal to 0. and that gives you that x is equal to 2. So we know the first coordinate, and then substitute 2 back into the original one. Which gives us -3. Okay, great. Now they've asked us the nature of the turning point. Nature meaning, is it a minimum point or is it a maximum point? And hopefully you remember, when you've got a quadratic that begins with x squared and it's positive, it means that it has a minimum point. Obviously, you'd have to explain it most of the time. They would ask you to explain it, and you just need to say it's positive quadratic, which must mean it's a minimum. And the final thing they want you to do is interesting, because they've asked you to find the equation of the line of symmetry for this curve. It's a bit of a strange question, but if you think about it, we know that this curve looks something like, we don't know where it crosses. We could obviously work it out, but it looks something like this, right? And the fact that it's got a minimum point, that's all we know. Like, it could be actually here. But the point is, we know it's got a minimum point. So with all quadratics, whether it's a minimum point or a maximum point, they actually have a line of symmetry that goes through the minimum or maximum point, or just goes through the turning point. Obviously, this only applies to these kind of quadratics, not where you've got x cubed, for obvious reasons. But when you've got an x squared, you can find the equation of the line of symmetry, because you know that it crosses through the turning point. And you should realise that we know the turning point is 2 minus 3. So actually, I've drawn it pretty accurately. 2 minus 3 would be somewhere there. But obviously, to find the equation of the line of symmetry, we know that it's a vertical line. So it's as simple as saying x is equal to 2. There you go. So the equation is x is equal to 2. So if you think about it, to draw x is equal to 2, you'd just be drawing a straight line that crosses through x is equal to 2. And that would be the line of symmetry for this curve. Great. We're going to do just one more question to solidify, and then we're done. So have a look at this question. So it's not to do with turning points in particular, but it uses the same skill. So they've asked you for the curve with the equation y equals 4x squared minus 2x plus 5. So first one is find dy by dx. So dy by dx, again, is pretty easy for us. Sorry, I wrote this wrong. It's 4x cubed. That's meant to say 4x cubed. Okay. So to differentiate that, we get 12x squared minus 2. Now the second point is coordinates for 2 points on the to find the coordinates for 2 points on the curve where the gradient is equal to 1. Hopefully you can see that it's going to use a very similar method to when we're trying to find the coordinates of a turning point, because the only difference is, instead of making dy by dx equal to 0, because we know the gradient at a turning point is 0, here they've told us the gradient at these points is 1, so we know we need to make dy by dx equal to 1. So let's do that. So 12x squared minus 2 is equal to 1. So 12x squared must equal 3. So x squared is equal to 3 over 12. So as x is equal to, very important to remember, it's plus or minus square root of 3 over 12. And basically the plus or minus square root of 3 over 12 is basically, the same as x either being 0.5 or minus 0.5. And remind yourself of the question, we're trying to find the coordinates for these 2 points. So we found the x value for these 2 points, we just need to find the y. And again, That comes by substituting both of these values into the original equation. And again, that is a skill that I'm sure you all have. So if you substitute x as 0.5, that would give you y equals 4.5, and this would give you y equals 5.5. Oh, sorry, looks like a 3. There you go. So your two coordinates must be 0.5, 4.5, and minus 0.5, 5.5. And there you have it. That's how you'd approach that question. All right. Thank you so much for watching, and please let us know if you found it useful or not, and if you have any questions, pop them in the comments. Thank you.